Grounding requirements for a home are crucial for safety and proper electrical function. Let's discuss the specific scenario of a home with plastic water lines, addressing ground rod placement, water bond considerations, and neutral ground bonding. Firstly, regarding the location of the ground rod, it should be driven vertically into the earth outside the home. Position it approximately 8 feet from the foundation and maintain a distance of not less than 6 feet from any buried metal structures. If multiple ground rods are required, space them at least 6 feet apart. Secondly, when connecting to the ground rod, use the 4/0 bare copper ground wire from the main panel. This wire should be connected to the ground rod using a ground rod clamp. Ensure the ground rod clamp is properly tightened to establish a solid electrical connection. Now let's address the water pipe connection. It is important to not connect the ground wire to any plastic water line, as plastic water pipes do not provide an effective ground path. If you have metal water lines, a water bond must be installed at the point of entry where the water pipe connects to the plumbing system. The water bond consists of a copper wire or bonding strap that connects the cold water pipe to the ground wire, ensuring that the connection is made securely. Let's move on to neutral ground bonding. The neutral wire and the ground wire should be bonded together at the main panel. Safety should always come first, therefore follow proper safety precautions when working with electricity. Use insulated tools and wear appropriate protective gear. Also, reference codes by consulting the National Electrical Code, NEC, or local building codes for specific grounding requirements in your area. Grounding the electrical system in a home is necessary to provide a safe path for fault current to return to the source. This path helps to trip circuit breakers or fuses, which will interrupt the flow of electricity and prevent electrical shock or fire hazards. When dealing with plastic water lines, the absence of a conductive water pipe necessitates a greater reliance on other grounding methods, such as ground rods, to ensure the home's electrical system is properly grounded. Ground rods are typically made of copper or copper-clad steel and are driven into the earth to provide a direct connection to the ground. The NEC specifies the requirements for grounding electrode systems, including the size and type of grounding conductors, the number and spacing of ground rods, and the methods for bonding various metal parts of the electrical system. In most residential applications, 2 ground rods are required to ensure a low-impedance ground path. These rods should be spaced at least 6 feet apart to maximize their effectiveness. The grounding conductor, often a 4/0 bare copper wire in the scenario, connects the ground rod to the main electrical panel. This connection must be secure and made with listed grounding clamps to ensure a reliable electrical path. Bonding refers to the practice of connecting all non-current carrying metal parts of the electrical system together to create an equipotential plane. This helps to minimize voltage differences and reduce the risk of electric shock. In a home, bonding typically includes connecting metal water pipes, gas pipes, and any exposed metal parts of the electrical system to the grounding system. Since the home has plastic water lines, the typical water pipe bonding is not applicable. However, any other metallic piping systems, such as gas lines, should still be bonded to the grounding system. The neutral ground bond is a critical aspect of the grounding system. At the main electrical panel, the neutral conductor, which carries the return current from electrical loads, is connected to the grounding conductor, which is connected to the ground rods. This bond ensures that any fault current has a low impedance path back to the source, which will cause the circuit breaker to trip and to energize the circuit. In a subpanel, it is important to isolate the neutral and ground conductors and not create a neutral ground bond. The subpanel should have a separate grounding busbar that is connected to the main panel's grounding system via a dedicated grounding conductor. This prevents circulating currents and ensures that fault current flows back to the main panel, where the neutral ground bond is located. When installing a grounding system, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for grounding and bonding electrical systems, and local codes may have additional requirements. It is also important to use listed equipment and materials that are designed for grounding applications. Improper grounding can create a dangerous situation that could result in electric shock, fire, or equipment damage. A licensed electrician has the knowledge and experience to properly design and install a grounding system that meets all applicable codes and standards. The electrician will also be able to inspect the system and ensure that it is functioning properly. In addition to the grounding system, it is also important to protect electrical circuits with ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small amounts of current leakage to ground and will quickly trip the circuit, preventing electric shock. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Regular maintenance of the electrical system is also important. This includes inspecting wiring, connections, and grounding components for any signs of damage or corrosion. Any problems should be repaired promptly by a qualified electrician. Remember, electrical safety is paramount. When in doubt, always consult a licensed electrician to ensure that your home's electrical system is safe and compliant with all applicable codes and standards. Grounding electrode system requirements of NEC Section 250.50 states that all grounding electrodes described in 250.52 that are present at each building or structure served shall be bonded together to form the grounding electrode system. When none of these grounding electrodes exist, one or more of the grounding electrodes specified in 250.52 shall be installed and used. Grounding electrodes are described in NEC Section 250.52. They include metal underground water pipe, metal in ground support structures, concrete encased electrode, ground ring, rod and pipe electrodes, and other listed electrodes. Since the home has plastic water lines, the metal underground water pipe cannot be used as an electrode. For metal and ground support structures, Section 250.52. A2 discusses that metal in ground support structures shall be permitted as a grounding electrode if it is electrically connected to the earth. The support structure shall be installed in direct contact with the earth vertically for 10 feet or more. If the metal in ground support structures are used as a grounding electrode, it needs to be assessed to see if it meets the requirements in 250.52. A2. For concrete encased electrode, Section 250.52. A3 discusses that a concrete encased electrode shall consist of at least 20 feet of either one or more brass or zinc galvanized or other electrically conductive coated steel reinforcing bars or rods of not less than 1/2 inch in diameter, or a brass or zinc galvanized or other electrically conductive coated steel conductor not smaller than 4 American wire gauge. The reinforcing bars, rods, or conductors shall be encased by at least 2 inches of concrete and shall be located horizontally within that portion of a concrete foundation or footing that is in direct contact with the earth, or vertically or horizontally within that portion of a concrete foundation or footing that is intended to be in direct contact with the earth. If a concrete encased electrode is used as a grounding electrode, it needs to be assessed to see if it meets the requirements in 250.52. A3. For ground ring, Section 250.52. A4 discusses that a ground ring shall be encircling the building or structure in direct contact with the earth, consisting of at least 20 feet of bare copper conductor not smaller than 2 American wire gauge. If a ground ring electrode is used, it needs to be assessed to see if it meets the requirements in 250.52. A4. For rod and pipe electrodes, Sections 250.52. A5 discusses that rod and pipe electrodes shall not be less than 8 feet in length and shall consist of the following materials. Firstly, electrodes of pipe or conduit shall not be smaller than 3/4 inch trade size and shall be galvanized or otherwise metal coated for corrosion protection. Secondly, electrodes of rod of steel or iron shall be at least 5/8 inch in diameter. Non-ferrous rods or their equivalent shall be listed and shall be not less than 1/2 inch in diameter. Rod and pipe electrodes shall be installed such that at least 8 feet of length is in contact with the soil. They shall be driven to a depth of not less than 8 feet. All rod and pipe electrodes shall be free from non-conductive coatings such as paint or enamel. Where rock bottom is encountered, the electrode shall be driven at an oblique angle not exceeding 45 degrees from the vertical or shall be buried in a trench that is at least 30 inches deep. The upper end of the electrode shall be flush with or below ground level unless the above ground end and the grounding electrode conductor attachment are protected against physical damage. If rod and pipe electrodes are used, it needs to be assessed to see if it meets the requirements in 250.52 A5. If none of these grounding electrodes exist at the building or structure served, then one or more of the grounding electrodes specified in 250.52 shall be installed and used. In this case, since there are plastic water lines, at least one ground rod is required to be installed. Based on 250.53 A2, a single ground rod is permitted if it can be demonstrated that the ground rod has 25 ohms or less resistance to ground. This would require performing a ground resistance test. The instruments used to measure ground resistance use the full of potential method or a 3-point test. This test involves driving 2 auxiliary ground electrodes into the earth in a line away from the ground rod being tested. The distance between the auxiliary electrodes should be at least 20 feet. A ground resistance meter is then connected to the ground rod and the 2 auxiliary electrodes. The meter injects a current into the earth and measures the voltage drop between the ground rod and the auxiliary electrodes. The resistance to ground is then calculated using Ohm's law. If a single ground rod does not meet the 25 ohms or less resistance to ground requirement, then a second ground rod is required. The 2 ground rods must be separated by at least 6 feet. If 2 ground rods are installed, then a ground resistance test is not required.